Hello, Miss Neville Science students. Today we're going to start talking about the inclined plane. The inclined plane is what we know of usually as a ramp. And we're going to talk about how the inclined plane makes work much easier or efficient. Our learning objectives today are going to be, we'll have two, so one that we'll talk about today and the other one tomorrow. But this recorded lesson will discuss how you can achieve both of these learning objectives. The student will be able to, that's you, to construct a model of an efficient inclined plane. Remember that word efficient means easiest to use. The student will also be able to, that's you, explain why the inclined plane is efficient. So after we make some changes to what that inclined plane looks like, how can we make it more efficient? So we need to understand that the inclined plane is a ramp. Okay, we see those on the back of moving trucks. We see inclined planes in most places, lots of different places. This is a great picture of one that you'll need to add to your notes today. Feel free to pause this video so that you can get the appropriate notes. Each simple machine, including this inclined plane, uses two types of force. We'll see two types of opposite forces acting on this inclined plane. Effort force, we see effort force in the man pushing up that load. And then we have resistance force. And your bullet here says it's an invisible force that pushes against the effort force. So the resistance force pushes against the effort force. So it's important for us to know that we can make the inclined plane the most efficient by making it a shorter ramp, making it less steep. So remember, efficient means easier to use. If we're going to make our ramp easier to use, we have to make it longer and shorter. Okay, so we want to increase the length of that inclined plane and decrease the height. We want to make sure we remember that when we're measuring force, and you'll see that today in your assignment that you have to do, when we're measuring force, we use newtons, and it's usually abbreviated with a capital N. Newtons are measured using a spring scale. When the effort force has more newtons than the resistance force, the load will move. So that means if I'm strong and I move that load, there's more effort force in my pushing than there is resistance force pushing back. When the effort force has less newtons than the resistance force, that load will not move. And we're going to be able to illustrate that today in our notes. When that effort force is less than the resistance force is stronger, and so I can't continue to push up.